this concept of type actually becomes absolutely critical. IMDb, Internet Movie Database, CDDB, these are unique databases of things. GS1, that is the industry for doing barcodes. User agents, the Mac codes that you get in IMEI. A good concept of types and device types is a fundamental industry enabler, and I believe is somewhat missing from sort of like the IoT ecosystem. So let's skip to some technical detail. This is actually what it looks like. So sort of jump to the end. It works. So at the far right, you've got the routers. So common garden routers, they exist today. They see MAC addresses, they see IP addresses, they say route your traffic. And you can have software controllers that sit over the top. But what we're trying to develop within the ManySecured vision is the concept of a ManySecured controller, a ManySecured policy, which can reason at a much deeper level about what it's seeing. Where it's appropriate, take an automatic response, which is quick, faster response to threats, but also embodies the possibility of escalating some of these issues to human security analysts as well. And on this side of the screen, you really see two sources of information that are critical. So, authoritative information sources pertaining to type, right? So these are basically, this is the type hierarchy, this is the hierarchy of mushrooms, but then it's the phenomenon that you are tied to those types. So vulnerabilities, you tie vulnerability to a type, not an instance. Behaviors, you define the behavior against the type, not the instance. SBOM, again, SBOM quite clearly is a declaration of dependencies of the type. So all of these informations relates to the type, and then the next box underneath, which is equally critical if you want to dynamically control the security, are the lifecycle events. And I think this is something that's largely missing in the IoT ecosystem at the moment, and it again is quite pivotal, is how do you track the life cycle of a device through all the steps. And a lot of this, the things I'm talking about aren't new. There are vulnerability databases, there are SBOM principles, there are dismiss threat detection. What is new is the method of making all of this information interoperable and usable at an operational level. And so the fundamental output, as far as the ecosystem is concerned from what we're doing, is really these definitions of these four interoperable interfaces. So each of these interfaces is designed to be as small and as simple as possible, but is defined in such a way that you can build out this ecosystem in lots of different flavors very rapidly. So fundamentally, you've got the concept of D3 events. So D3 events are literally the high-level instance behavioral metadata. It's a log. It's a network log, but stripped down. It's a PCAP filter, but stripped down. But it's the subset of network activity that's important and material to making security decisions. You've then got the D3 types. So the D3 types is essentially your hierarchical type data and the security metadata you can attach to it. You've then got a newer thing that we're just developing at the moment, which is the lifecycle events, which really take you through from manufacturing to provisioning to commissioning to end of life, but again, all critical. And then finally, you've got what we call the D3 con, which is the control layer. So, okay, you've absorbed the phenomenon, the behavior, you've reasoned intelligently about your risk profile, you want to do something about it, what do you do about it? Typically, there's a finite number of things from kick the device off the network segmentation, constrain the network, constrain the device, etc. So fundamentally what this is, it's a vision of an intelligent control loop that you can sit on top of any routers. And it's extensible. We can add in, although the D3 events basically looks on basically a subset of PCAP capture, you can add in extra data. You can do port scans, you can do virus scans, you can do vulnerability scans. Within this model, you can layer in extra information if you so desire. And also, it will work in a lot of different architectures. a lot of the work we've done to date has largely been on consumer gateways, but it can work off a network tap, a network span, it can work off an industrial gateway, and we've even got some demos running on 5G and LTE networks. So that's the vision, and in the next part of the slide back, I'm essentially going to break it down into what I call essentially value-added features, all of which are made possible because of the underlying technology. But just one thing that might make your brain hurt a little bit, and I won't dwell on it too much, but we can talk about it afterwards. But one of the things that's unique about this vision is there's no single source of truth. So under the hood, it uses, the equivalent of digital certificates. But it doesn't make the mistake of a lot of classic sort of like PKI implementations where it always renders to a yes or a no. We're fundamentally addressing a complex problem where we're dealing with legacy devices and uncertain information, so that the way that the information is daisy-chained is to allow for both opposite source of truth, different sources of truth, but also subjective interpretation of truth. My truth is not the same as your truth. Somebody in the UK might have a different set of trust foundations when it comes to security metadata to someone in China, for example. And so the framework actually embodies that reality of the world. And then the other reason it is the way it is because devices outlive manufacturers, especially in frothy things like IoT devices. You can buy stuff today, that device will still be working long after that manufacturer has ceased trading. So we need to handle that. So how does it help? So I'm now going to step through a set of features that we think are all important value-added capabilities that this technology enables. The first one, quite simple, counterfeiting. So it might sound like a simple question to answer. So from the router's perspective, is this device the same the device that I saw yesterday? It sounds simple, but it's a lot harder under the hood because you can't rely on IP addresses because obviously they rotate. MAC addresses, especially with the new privacy legislation, they rotate. So if you're observing at the router level, what have you got that's stable? And then if you overlay the ability that MAC addresses are really easy to spoof as well, you start to realize you've got some weak foundations. But by implementing this type of architecture, by registering deep identities, by having a sense of how strong that identity is, and seeing if it's registered elsewhere collaboratively, it gives you the foundations that you need to be able to spot spoofing and counterfeiting much better. Next one, updating. So all the good IoT security guidelines say you must keep your device updated, but how are you going to do that? Not all IoT devices can autonomously update, so therefore they require user intervention. So if you've got 100,000 light bulbs connected to a router, how are you going to know sort of like when they need updating, especially if they're coming from different manufacturers? So by putting this sort of like chain of reasoning and chain of evidence in place, so we know that we've got a device instance, we can estimate what the device type is, we can implement a number of methods to identify what version of firmware is currently on there, and then we can compare that to an external declaration of supported for a piece of firmware. It doesn't solve it completely, but it puts a lot of the building blocks you need in place to be able to do this very simple thing, keep your devices updated, but to do it practically and at scale. And then the next one is, it's sort of like it's a slightly orthogonal to the other requirements, because increasingly, the more I look at it, the more I see onboarding as absolutely vital to everything. This is the life cycle event, probably the most important life cycle event, where you can actually practically implement all of these important security controls. So, and some of this always goes back to security, always, because without that, a lot of the things northbound break. So, but the type of questions I could ask myself as the router that's onboarding the device is, so do I recognize the device ID? Is it a unique ID? Has someone seen it before? That's the counterfeiting problem. Has someone purchased the device? Has the owner of the network actually purchased this device? So this is one of the flows that sort of like NIST's looking at quite intensively at the moment. But actually, if you can do that, if you can dovetail the record of the device purchase with the actual onboarding device, that's really quite powerful. Has the device been provisioned? So has someone trusted introduced this device to this network? Is it an attestable device instance versus, so that's really looking at, well, that single bullet point hides a whole host of complexity in terms of how deep do you do that attestation. But clearly a level of attestation is always useful. But then over and above testing the device instance, you then need to start thinking about, so that's a testing to the device instance. That's being sure that what's declared is what is. But then what about testing? You know, if you're in a scenario where each individual device needs testing before you can onboard it, it's a perfect place to actually implement this check. And then over above testing device instances, you've got also testing device types. And the two things are quite different. You know, testing a device instance, putting probes, playing with it. Testing a device type is for example, something like, you know, the ITSF compliance framework or whatever will come out of the various EU or sort of like US legislation. There will be a test that underpins that. That test will be applied to type. But if you want to operationally use that, you need a system like what I'm describing to touch those together. Okay, and so if onboarding is one thing, what about offboarding? So this is how you mitigate. It's the inverse, right? This is the far end of the life cycle. But the three big sub-classifications of when you want to offboard. Well, if it's resold. So if you have recorded the fact that it's sold and it being sold to that user is key, then obviously it being resold is something you need to record and act on sensibly. Counterfeiting, so there's a whole load of attestations that go under that. And then the final one, which we'll start to come onto more and more, is the irregular activity. And this is where all the dynamic stuff starts to come in, because fundamentally, you know, if you don't have absolute trust in the underlying identity of the device, all you've got to do is look and see what it does and use its behavior to determine its trustworthiness. Right, vulnerability inferencing. So, the simple ways of doing this and complex ways of doing it, to some extent, CVE databases give you some of this. So what is a CVE database? It is a declaration there is a vulnerability against this thing. So great, if I can go from instance to type and from type to vulnerability, then at real time my router then can actually know about that and do something about that. And I've called vulnerability inferencing 2 because you can add SBOM into the equation. So from a security perspective, what does SBOM do? It really just gives you a set of sub-dependencies. Because the point is, when you declare the vulnerability, what are you declaring the vulnerability against? That's quite a complex question in its own right. But SBOM gives us basically a set of sub-components on which we can identify vulnerabilities and then reason on it. So the inverse of that vulnerability reporting. I think Peter touched on this in the panel earlier on. So if I see this device doing something odd, that's interesting. If I see two instances of that same type doing something odd, then that's a much bigger evidence space for me to actually then register a vulnerability against the underlying thing. And then we got some suspicious activity inferencing. So the MISP database is probably a good starting point for this. In a minute, I'm going to start talking about positive patterns. This is really an anti-pattern. There are certain behaviors you can observe on a device which are highly indicative of it being compromised. There are databases that exist that allow you to download this information, but there isn't sort of today a good method of interoperably reasoning through that chain to be able to go from, I see this device doing this thing matches this pattern, and therefore I can flag the risk. So the next, sort of like the final sort of like few requirements are sort of like the inverse of this, which is, whereas that is looking at activity and sort of like spotting something that's suspicious at the instance, this is really now all about containing a device. And this is already being done in industry. There's something called IETF, MUD, Manufacturer Usage Description. It's essentially a permissive pattern of behavior. Because at the point of manufacturer, you know more or less what it should be doing, and that doesn't change very much, certainly not on an IoT device. It has what we call sort of like a low volatility. So it seems quite a simple thing to do then, is if I have a reliable description of what this device should do, essentially a whitelist, a permissive list, then now I have a mechanism for policing it or reporting on it. So that's least privilege. It's got two more things, I'll just squeeze them in quickly. So least privilege is a whitelist. But to some extent, the really interesting stuff, and I think this is the stuff John's going to be talking about straight after me, is the stochastic behavior. A whitelist is good, but it's quite simple. But actually, if you monitor a device over a period of time, you can start producing some very interesting and reliable statistical patterns of behavior. And to some extent, a lot of the machinery that sits under the ManySecured is essentially to build the framework to make this work at scale. So the last two pieces that I'm just going to throw in there because they dovetail with some of the digital secure by design work. It's fully integrated in a concrete system in a useful way, and it really forms the foundation of a useful collaboration. And everything that I'm talking about is very practical and very concrete. I've talked about the conceptual stuff. All of this stuff is fully spec'd out and in the open source code and is demonstrable out there. And we're continuing to try to grow the community to help further this work and mature it into more and more real world applications. Thank you very much.